So, in this exercises, we will continue our labs and demonstration of creating Kubernetes clusters, managing and operation. So, in this exercise number one, in this exercise number one, we have a namespace called SKTrade system, and the exercise says SkyTrade Corp infrastructure team at Stock Trading Division needs a lightweight health monitoring pod running directly on the control plan node. So they need a lightweight health monitoring pod to be run on the control plan node, managed by the kubelet and dependency of the Kubernetes API services. So we are in node 9321. So the exercise was, well, let's see which node we have. Got nodes. We have only one node, control plan and worker. The question says, create static pod named Sky Health Check. It should belong to the namespace SkyTrad system. Use the image nginx 125. Add the label tier infrastructure to the pod. Place the pod in a manifest in the appropriate kubelet static pod manifest directory and ensure that the pod reach the running state. So the question is to create standalone pod, and just we need to check kubelet. Create on the kube admin base cluster. The static pod manifest directory is in the folder, this folder. So here we find the manifest directory of the static pod. We can verify this by checking the kubelet configuration or by inspecting the kubelet process and grab the manifests. On the kubelet cluster, you will already see the control plan component manifest, kube API service, cd control plan, and all in this directory. Let's see first what is the kube manifest. So here, okay, sorry. Okay, here it give us the folder that I already showed before. So etc Kubernetes manifest, and in this folder we will find all the manifests that are using by Kubernetes. Okay, now the second question. I will make a zoom. The second question is to create the pod using, we have two approach using the kubelet command. So I will just give the command without executing it. So kubelet run the name of the pod skyrock skytrad health check image 1215 label. So it said add the label tier infrastructure and use the namespace care thread system. Okay, I said moi Jairan client. This will not execute the command. It will just give the UML of the file and create a YAML file of this command here in the etc Kubernetes manifests skythread health check. We can do so. It's created. So it's file. It's a container YAML file creating its pod label tiers, the name and the namespace, the container image and the container name without any other parameters. So after creating, we can execute the command line and we will verify that the pod name in the API server will have the mod name appended. For example, skythread health check. So okay, apply and we can see that the pod is created in the namespace. I have created it twice, I think, the first and the second one. But the most important is that on the kubeadmin cluster, the etc Kubernetes manifests already contain control plan static pod manifests, etcd kube API container. These all the pods that Kubernetes use for its operations. The static pods are visible via kubectl get pods as mirror pods, but they cannot be controlled through the API server. This is the difference between the static pods and the control plan static pods. This is the difference. So if we delete static pod through the kube control, you will not remove it permanently, but you must delete is the manifest file from the node. But the kubelet periodically scan the manifest directory. So thus the pod should appear with the new sequence. So here, why we have two pods? Because I have created a static pod, a static manifest here, as it was explained by the exercise. Place static pod manifest in the appropriate kubelet static pod manifest directory and I set the pod and I have applied again. So if I will delete it, so I will delete pod I will delete both the pods. The one that was applied manually and the one that was created by the Kiblet service. And we can see that one pod is already running. And this is normal because we already put it in the Kubernetes root manifest directory. So if it is here, it will scan always by Kubernetes and it is launching again. So the second exercise, so in the cluster CKA 2025 44 in the namespace trading, it says a security compliance team at SkyTrade Corporation has flagged that the stock trading engine microservice in SkyTrade trading namespace is currently accepting traffic from all resources within the cluster. So there is no limitation there is not no network policy, and if there is a deployment in one project, it can connect with this trading namespace. This violates the zero trust network policy, and this is very important for new deployments and security compliances. So the question is to create a network policy named restrict trading ingress in the stating in the state in the SkyTrade trading namespace. The policy must target the pod labeled and then all network TCP traffic only on port 18 and that only from ports in another sky namespace called Sky Trade API namespace that carry the label rule gateway. Very important. So then we will accept only from another namespace with this label. All other ingress traffic to trading engine post may be blocked. So to create this network policy, okay, I will check get all. And okay. So in this spot, we'll create network policy via network policy dot yaml. Okay, I will my keyboard and we'll create the network policy as explained here. So this is my network policy. It is a network policy with the name restrict trading ingress in the namespace sky SkyTrade trading. We have one uh, policy must target pod only with the label trading engine. So if I have pods in this namespace without this label, it will not be applied. And this is uh, one like in tagging in VMware or other cloud platform. So the policy will be applied only in ingress. There is no egress. So the egress, all the egress traffic is disabled. In the ingress, we will accept only traffic from at SkyTrade API namespace. So here we have this condition match label. Well, this is metadata name, but we can use only name. So no need to complicate the things. Name. So this namespace, it will accept only from namespace SkyTrade API, but only with pods selected that the pods in the gateway role, not all pods in this name this namespace and the port. This is the port that will accept to traffic come in ingress TCP 8080. So we apply the policy, apply, and you can see the policy is applied. Donc, okay, described. We describe to check the policy. The policy in the namespace sky trading. Okay, here we can see that the policy has been applied and will accept only traffic from namespace SkyTrade API and only with pod with the role gateway. So not affecting egress traffic, policy type ingress. So here the egress traffic, if there is an egress traffic, it will be blocked. Sorry for my mistake, because there is no egress traffic explicit configuration. So if if there is no explicit traffic, the traffic is allowed. If there is explicit configuration but without role, the traffic is disabled. Okay. Next exercise, we have namespace called SkyTrade payment now, and the payment processing team at SkyTrade Corporation reports that their payment gateway service in trade payment namespace is not routing traffic to the backend pods. So let's go inside, and you can see everything from this namespace. We have two pods, one deployment and one service part. It says that namespace is not routing traffic to any backend port. Even the service is here. There is no traffic from the service to the pods. So customers cannot enable to complete stock purchase transaction. What happened before? A junior DevOps engineer created deployment and the service earlier today. This is the deployment processor. Deployment pods appear to be running normally. It's all, but the service has no endpoints. So if we can go get endpoints, endpoints. Okay, sorry. So there is no. Oh, sorry, not payment. The endpoint is not connected to the service. So the question is investigate the issue and fix so that the payment gateway service correctly routes traffic to the pods managed by the payment processor. Deployment do not delete. Okay. Do not delete or recreate resources. Fix the existing. Generally, this kind of problem is related to the pod selector. So if you can go inside the deployment, edit, deployment, payment processor, we can see that the label here is called payment SLV, payment service. Okay, here, payment service. Okay, other parameters are related to deployment. Sorry, each time the problem of the. You can go now to the service. So the service is, if we can go to the service, we can show that the selector is not the same as pod selector here. Okay, pod selector, single stake, pod, payment gateway, scaled payment, history, EP. Okay, this is here is called payment processor. And in the deployment is payment as service. So we have to change here or in the deployment. Very important in the deployment, it is not possible to edit the deployment and change the selector without creating a new one. So we have to make a rule out and create a new version and change the deployment. But in the service, we can change it here. So you can put only just the deployment name here, and okay, can see that if it will work. Okay, repeat. Can see now the gateway are referenced to the describe. We have created this the endpoint, the image gateway, and the endpoint should now show the pod IP addresses. So always start to get the get endpoint name to check the endpoint. If it's empty, compare the service selector of the pod with the labels on the services. If the endpoint exists but the traffic files, verify the target port also sometimes is not match the container port. The describe command always for comprehensive overview and for the endpoint. Next exercise. So now we have scattered orders namespace. The order management system ScateRite Corporation require persistent storage processor. Now we are in the storage and retaining stock purchase order records. So they need a persistent storage. The platform team has asked you to provision storage using a host path volume of the node. So can go inside the cluster, can see the close get storage class. I have already one storage class and it is the default one, and we will use this storage class. The question not asked to create storage class, it's asked to create persistent volume, so with capacity. So we will create manual persistent volume static. We will not ask because there is two ways to create volume in Kubernetes. First is to use statical. So the Kubernetes administrator will create manually the volume, and the second one, and this is the Kubernetes design, uh, uh, most important function of Kubernetes is that it's possible that the cluster we will create the volume for your all infrastructure, pods, deployments, everything. Here it's asked to that the administrator will create this for us. Then we will create persistent claim always because the pods and the deployments always reference to the volume by persistent claims. And these persistent claims will use the volume already created in step one for the storage class. The manual storage class is always the one that the default we can use to create manual static volume. If We have other storage class in